All right, we had a little technical glitch there, so that's why these two are separated. Now we're set up, and we're going again. But now for our vertical asymptote, we've already found our horizontal, which is 1. We're going by our exponent rules. Now, if we look at our vertical asymptote, though, all we have to do is set this equal to 0. So we'll have x minus 4 is equal to 0. Add 4 to both sides. You have x is equal to 4. So that is our vertical asymptote. Okay? So we just set the bottom equal to 0. Okay? So these notes are going to be very important as you do the other 3 as well. I'm not going to write those notes down, but we will talk about it as we go. All right? So you can look back and just look at the notes and the steps that you have for this one. All right, for when you're looking at the domain, the easiest way to do this is to look at your vertical asymptote. Now, I have a vertical asymptote at 4. Now, if you remember on a graph, that means at 4, I have 1, 2, 3, 4. At 4, I have a line that my graph never touches. So my graph may do something like this, and it goes on, but it never touches at 4 right there. So for my domain, it would be all real numbers except 4. All right? Now my range is going to do the same thing, except I'm going to look at my horizontal asymptote. And that means that I have an asymptote going along somewhere like that. So I'm going to go up, and I'm not going to hit that one point, but I will hit every other point other than that. So I have 1, so all real numbers except 1. And that is my information for number 29. And I know that some of it's on one video, the rest of it's on this one, but it'll be okay. All right, let's look at number 30. You have x squared minus 4 and negative 4x squared minus 16. All right, so remember for our zeros, we're going to set the top equal to 0. So if I set this equal to 0, I have x squared minus 4 is equal to 0. So I'm going to add 4 to both sides, so x squared is equal to 4. And then since I have a square, I'm going to take the square root of both sides, and x is equal to plus or minus 2. So my zeros are plus and minus 2. So I'm going to cross the x-axis twice for this graph. And I can tell that because of this right here. That exponent lets me know that it is going to cross, it's going to have 2 x's. Now my y-intercepts, it's when I plug 0 in for all my x's. So if I plug 0 in here, and I plug 0 in here, then I'm going to have 0 minus 4 and then 0 minus 16. So I will have negative 4 over negative 16. If I simplify that, that is 1/4. All right, my horizontal asymptote, I'm looking at my exponents. If I look at my exponents, I have the same. I have a 2 and I have a 2. So since they're the same, I have to look at what's in front. I have a 1 here, and then I have a negative 4 here. So I'm going to have 1 over negative 4, and that will be my vertical, or my horizontal asymptote. All right, my vertical asymptote for this one, and this one is a little messed up because it does end up giving you an imaginary number, and we're not dealing with that. But I'm just going to go ahead and give you the answer for this one so you don't have to do that. But it'll end up being plus or minus 2i. But we're not dealing with these, so that will not be on your test. It will be one where you find an exact number like this one over here. Okay? All right, so for my domain, I'll look at my vertical asymptote. So I'm going to have all real numbers except, sorry, I didn't even spell that right, except plus or minus 2i. Now, for my range, I'm looking at my horizontal asymptote. So it's going to be all real numbers except negative 1/4. And that is my answer for those two. All right. And I'm just making my page a little bigger so you can see it better, or so I have more room to work. But number 31 is going to be x plus 2 over 2x plus 6. Now my zeros, what do I do for my zeros? Take a second. I encourage you to pause this and go back and see if you can actually solve this before I do it to see if you're understanding. So that way you know, or if you want to pause and look at one and then pause and try the second one, so that way you can make sure there's nothing you're missing, and if there is, you can get it clarified real quick. But my zeros, I'm going to set my top equal to 0. So if I set this equal to 0, I'm going to have x plus 2 is equal to 0, subtract 2 from both sides, and x is equal to negative 2. So negative 2 is my zeros. All right, next is my y. I just plug in zeros for my x, so then I'm going to have 2 over 6, and if I simplify that, that's 1/3. Horizontal, I'm looking at my exponents on this one. My exponents are the same. So in front of this one, I have a 1, and then I have a 2, so 1/2. My vertical asymptotes, I'm going to set my bottom equal to 0, so I'm going to erase this real quick and do the work to the side. So 2x plus 6 is equal to 0. Subtract 6 from both sides, that gives you 2x. It's equal to negative 6. Divide both sides by 2, and x is equal to negative 3. So my vertical is negative 3. Okay? Now this goes to the part where I can look at all of that, or look at my horizontal and my vertical to find my answers for these. So my domain, I'm going to look at my vertical asymptote, and I have a negative 3, so it's all real numbers except negative 3. For my range, I'm going to look at my horizontal, and I have 1/2, so all real numbers except 1/2, and you're done with that one. All right, let's do this last one on this set. You have x squared plus 2x over negative 4x plus 8. All right, so now I need my zeros. I'm going to need my y, my horizontal, vertical, domain, and range. All right, so I'm going to end up having 2 x values, or 2 zeros, because this right here lets me know that. So I'm going to set it to the side. Now I can pull out an x when I go to factor this. Remember, greatest common factor. And when I pull out an x, then I'm left with x times x plus 2. Now if I look at this, if I multiply those, I'm going to get x squared. And then if I multiply these two, I'm going to get 2x. So I know I've factored it correctly. So I'm going to set each of these equal to 0. So x is equal to 0. I'm done with this one. So one of my zeros is going to be 0. Then I need to set this equal to 0. So x plus 2 is equal to 0. Subtract 2 from both sides, and x is equal to negative 2. So I have 0 and negative 2. Those are my x-intercepts or my zeros, if you want to look at it that way. I'm going to go ahead and erase this. Now you can pause these videos so that way you can get this stuff down quicker if you want. That way it doesn't mess you up with me erasing them. So just remember, you can go back on these and get what you need. Now, for y's, I need to plug in 0 for my x's. So I'm going to have 0 plus 0 on top, so that's going to give me 0. And then 0 plus 8, so that'll give me a positive 8. Well, 0 divided by anything is going to be 0. So my y-intercept is 0. All right, my horizontal asymptote. I look, I have a 2, and I have a 1. So my 1 on top is bigger, so that means I have none. All right, my vertical asymptote. I'm going to set my bottom equal to 0. So I have negative 4x plus 8 is equal to 0. Now I'm going to subtract 8 from both sides. So I have negative 4x is equal to negative 8. Divide both sides by negative 4, and x is equal to 2. So I'm going to have a vertical asymptote at 2. All right, my domain. I'm looking at my vertical, so all real numbers except 2. And then for my range, I'm looking at my horizontal, and since I don't have one, it's all real numbers. And I'm finished with that set of problems. Now this next set, you're just looking at the graph, and I know you don't have the graph on number 33 and number 34. And if you look as well, I have changed the problems just so they would work out good. But if you look at the graph, you'll be able to find where it's increasing and where it's decreasing. And then your zeros and your y-intercept. Y-intercept is where it crosses the y-axis. X-intercept or zeros is where it crosses the x-axis. So I'm going to write in black through all of these just so that way this blue doesn't clash with anything and you can keep it all separated. But if I look at this first graph, my zeros or my or x-intercept is where it's going to cross right here. Now, if you look, I have -4 and -5. So if you cross, and this should be somewhere right in there. So -4, -5. This lets me know I'm counting by twos. So 2, 4, 6, like that. And so my zeros where I cross the x-axis is going to be -5 because I have, hang on one second, let me look at this. It's going to be at 1 and -5. So -5 and 1. Those are my zeros. So I cross the x-axis at 0 and -5. Sorry, 1 and -5. Now my y-intercepts, where do I cross the y-axis? This right here lets me know that because my x is 0. So my y-intercept is going to be -5. Now increasing and decreasing is going to be an x value to either, with this one it's going to be either -infinity to whatever number or whatever number to positive infinity. And it's going to be, each of these will take one of those. So if I'm reading left to right, what is my graph doing? I have an arrow on this end, I know that, but if I'm going left to right, this graph is getting further and further away from me. So it is decreasing up until this point on my x. So it's going to be negative infinity to -1, and that is my points of decreasing. Now, if I look from here and I go over left to right, I'm just using my x values. So -1 to infinity. And that is my answer for those. All right. For this one, my zeros, where does it cross the x-axis? Well, as you can tell, I'm probably not going to have any because it is too high up. So you can just put none. Now my y-intercept, where does it cross the y-axis? And we can use this right here. That's why I wrote these ordered pairs out so you can count by twos. This is 0, 2. So where my x is 0, my y is 2. So I have 2 as my y-intercept. Now, all I have left is my increasing and decreasing. Let me pause this video 1 second because I'm having mess ups with this again. So let's see what we can do.